Hello. This is a test study guide for the test on tomorrow, Wednesday. If you notice, we're going to go quickly through this. This is acids, bases, and thermochemistry. So we're going to go ahead and start on question number 1. It says choose correct completion of the ionization equation for sulfuric acid that follows. This might be a little weird at first, but if you notice, what is H2SO4? Is that an acid or a base? Good, that's an acid. How do we know that H2SO4 is an acid? It begins with hydrogen. Good. So we have acid reacting with water. And what do we know about acids? When they react with water, since they're electrolytes, they are going to separate into their respective, ions. So H2SO4 is going to separate into its respective ions, hydrogen and sulfate. So if we look at that, where is one of these options? Well, if you notice, question or answer A, that's not correct because A still has water in it, so that's not right. Acids will totally dissolve into their respective ions, especially if it's a strong acid like H2SO4, sulfuric acid. B, under the same logic, it's not going to be the correct answer either. If you look at D, nothing happened, right? That's still H2SO4, that's still sulfuric acid. So if we look right here, we have 2 moles of hydronium and some sulfate ions. But you might say, Mr. Allen, we have hydrogen ions and sulfate ions. That's not hydrogen ions. But if you think about it, hydrogen, when it's an ion and it reacts with water, that should form hydronium, correct? So that is going to be our answer. Number 1 is C. Number 2, identify the acid from the following list of compounds. If you remember, the way to identify an acid is that it has to begin with what element? Hydrogen. Good. So that's D. Number 3, identify the base from the following list of compounds. Every base has to have what in it to be considered a base? Correct. It has to have a hydroxide ion. So which one of these has a hydroxide in it? B. Therefore, that is a base. Number 4, what are the products of a reaction between an acid and a base? And by the way, what are reactions called that react with an acid and a base? You should know that those are known as neutralization. Now, when an acid and a base react in a neutralization reaction, it's a double replacement reaction, right? Their products are going to be salt and hydrogen gas? No. That's close. Water and hydrogen gas? No. That's big no. Water and hydrogen gas? No. That does not make sense. No. Water and oxygen? No. That's not right either. You should remember this fact that neutralization reactions always have as their products salt and water. Number 5 says, which of the following describes Al2SO4 that's aluminum sulfate? Is that an acid? No. Why not? Why is that not an acid? Because acids always begin with hydrogen, so that's not an acid. Is it a base? Well, what do bases require? Bases require hydroxide, so is it a base? No. Now, we have these 2 options over here, salt and hydrates, and we've never talked about hydrates in this class, and it's not a hydrate. Hydrates require water, and that's not one. It's got salt. Number 6, what type of ion does an acid form in an aqueous solution? You should know this like the bottom of your heart, hopefully. It's not chloride, it's not water. Hydronium, H3O+. By the way, what does hydroxide look like? OH-. So which one is correct? In an acidic solution, should be hydronium. Okay. What distinguishes a strong acid from a strong acid from a weak acid? You notice question A, or the answer A, strong acids have a higher pH. Wrong, because the higher the pH, the what? The more basic. So it's going to have a lower pH. Strong acids have more acid particles present. Not necessarily, no. No. The reason why we're going to know the answer is C, and by the way, weak acids, they can hurt skin. They can. The reason why we know it's C is that strong acids, by definition, they're known as completely dissociating in water. That should be in your notes somewhere. Strong acids will completely dissociate in water. That means that an H2SO4, when it goes into water, it's going to totally, completely, 100% separate it into its respective ions. Not a little bit left behind. So that's C, number 7. Then number 8, what combination of acid and base will produce the salt beryllium chloride? Again, beryllium and chlorine. What do you think? Well, let's look at each of its answers. And by the way, beryllium has a +2 charge, according to the periodic table. Chlorine has -1. On question A, it says beryllium hydroxide and hydrochloric acid, but notice what's wrong with that. Something should make you feel a little nauseous looking at this compound. What feels nauseous? The fact there's a 2. That's a huge... So it's not A. If you look at letter B, we have hydrogen, but it's also bonding with beryllium. What do we notice about both of their charges? Hydrogen has a plus charge and beryllium has a plus charge. No. Don't put 2 of the same cations together, 2 of the same anions together. No. Are you silly? Don't do that. Same way over here. Don't do that. No. So that's also wrong. Question number C. Beryllium hydroxide, that looks good. And hydrochloric acid, that looks good. By the way, beryllium had a +2 charge, right? So each element's charge becomes the other element's subscript. So C is a major contender, and we can look at D just to make sure. Hydrogen is a positive ion. Beryllium is a positive ion. That doesn't work, right? We have to have different charges if they're going to be a compound together. So that won't work. So the answer is C. Number 9, you should be able to name any one of these acids or bases with fairly calm confidence. If you notice on H2S, is there an oxygen present? No. So that means we're going to have to use what prefix? Hydro. Since we don't have oxygen, we're going to have to use hydro as our prefix. So it's going to be hydrosulfuric acid. By the way, I have been seeing a lot of hydrosulfic acid, and while that's really good reasoning, do remember, sulfur will retain its main root. So hydrosulfuric acid. NaOH is just going to be a normal base, sodium hydroxide. H3PO4 should be, we have O inside of it, so what prefix do we not have? We don't have hydro. And by the way, what is PO4? PO4 is phosphate. So if it ends in 8, that has to become what? Ic acid. So it's going to be phosphoric acid. Not phosphic acid, but phosphoric acid. Up here, do we have oxygen present? Yes. So what prefix is not going to be present? We're not going to have any hydro. So we're going to go straight into it. What is ClO2? Well, that is chlorite. And if it ends in ite, that means it's going to turn into what? Chlorous acid. The next base, we got calcium hydroxide. Again, that should be fairly straightforward. And then the last one, do we have any oxygen in this last acid? Nope. So if we don't have oxygen, we have to use the prefix hydro. And then what are we doing? What's our nonmetal? Bromine. So it's going to be hydrobromic acid. Good. Now the next one, number 10. Write the formula for the following acids and bases. So we're going to do the same thing, but in the opposite direction. So ready? Perchloric acid. We know this is perchlorate. That's what it's dealing with. And by the way, that's one of our 6 strong acids you need to have memorized. So you should know that that is a strong acid. Perchlorate, since it's an acid, is going to start with H, hydrogen. And then chlorate itself is ClO4. So that's perchloric acid. Aluminum hydroxide is going to be AlOH. Will we have any subscripts? Yeah, because aluminum has a +3 charge and hydroxide has a -1 charge. Since they do, each element's charge becomes the other element's subscript. Good. Barium hydroxide, so barium is Ba. What charge does barium have? Looking at your periodic table, it's in group 2, so it has a +2 charge. Hydroxide has -1 charge. Each element's charge becomes the other element's subscript. Then, next, we have hydrophosphoric acid. Since we have that prefix hydro, what does that mean we don't have? We do not have oxygen. So that means it's just going to be hydrogen bonding with what? Phosphorus. Now, do we need any subscripts? Well, let's look at their charges. Hydrogen is +1. Phosphorus, according to the periodic table, is -3. Each element's charge becomes the other element's subscript. So it's H3P. That's hydrophosphoric acid. Sulfuric acid, again, since there's no hydro, that means this is an oxyanion that's going to have oxygen present. Since it's ic acid, we know that it was sulfate, which is SO4 -2 charge. Hydrogen has a +1 charge. Cross their subscripts, their charges. Sulfuric acid. By the way, this is another strong acid, so you need to make sure you know that one. And is nitric acid also a strong acid? Oh, yeah. Nitric acid, if you remember, ic means 8, so it's nitrate. Since it's an acid, it has to begin with hydrogen, and each element's charge becomes the other element's subscript. So since we do have a positive charge on the hydrogen and a negative charge on the nitrate, then we're not going to have any actual subscripts themselves. On to the next page. If you notice, these are a lot of mineralization. Reacts with active metals to produce hydrogen gas. That's going to be an acid. What do we call those types of reactions? Corrosion, right? Forms hydroxide ions in water. Base, because that's hydroxide, right? OH minus. H2SO4, is that an acid or base? That's an acid because it begins with hydrogen, right? NaOH, that's a base because it ends in hydroxide. Neutralizes acids. That should feel pretty straightforward. We use bases to neutralize acids. BaOH2, again, that's a base. Tastes bitter. Bitter, B. That's going to be another base. Do you remember how acids taste? Acids taste sour, right? pH equals 5. If you remember, if it's a pH of 1 to 7, it's going to be more what? Acidic. So if the pH is 5, then that's going to be an acid. Forms hydronium ions in water. Again, that's an acid. And then HNO3, since it begins in hydrogen, that's going to be an example of an acid. Okay, next, number 2. Predict the products for the following chemical equations. Do not worry about balancing. You will not have to worry about balancing on this test. I will give you the answers themselves already, so no worry about that. Note, we have an acid reacting with a base. What is that called? That's called neutralization. Good. In neutralization, what type of reaction is going to take place? It's going to be a double replacement. And by the way, I'm going to go ahead and switch my color from red to blue because red's been a little scary. Not scary, aggressive. The cations are going to switch places. And by the way, what's going to always be one of our products? It's always going to be water. It's going to be one of our products, as well as the salt that we form. How do we know the salt that we formed? Well, hydrogen just took the place of magnesium, so that's how we got hydrogen bonding with hydroxide to form water. And so magnesium is now going to be bonding with nitrate. Magnesium is now with nitrate. Now make sure you have the subscript correct. What charge does magnesium have? +2. What charge does nitrate have? -1. Each element's charge becomes the other element's subscript. So there should be a subscript 2 outside of nitrate. The next one, we have hydrochloric acid reacting with calcium. Note, when we have an acid reacting with a metal, what type of reaction is that called? That is called corrosion. And that's going to be an example of a single replacement. So in the green, I'm going to show that. Calcium is going to take the place of hydrogen, and hydrogen is now going to be by itself. So hydrogen will be by itself. Hydrogen gas is one of the products. And now calcium is with chlorine. Do we need any subscripts? Yes. Since calcium has a +2 charge, chlorine will need a 2 subscript. The next one, I'm going to do it in yellow. We have an acid, carbonic acid, and a base, potassium hydroxide. Double replacement, so the hydrogen is going to take the place of the potassium. This will leave us with the following products. If you remember, what is always one of our products in the acid-base reaction has to be water. And if you notice also, potassium is now bonding with what? Potassium is now with carbonate. Do we need subscripts? Let's look. Carbonate has a -2 charge, right? Potassium has a +1. So we are going to have a subscript beside potassium, K2CO3, potassium carbonate. By the way, make sure that you're able to name any of these salts. Potassium carbonate. That should be some good review from chapter 8. Then the last one, we got another acid. This is sulfurous acid. By the way, is sulfurous acid a strong acid? No. Sulfuric acid is strong, but not sulfurous. Not sulfurous. This is sulfurous acid reacting with sodium. What type of reaction is this going to be? It's going to be a single replacement, which we know as corrosion. One of the reactants, or excuse me, one of the products is going to be hydrogen gas, and the salt that is formed is going to be sodium sulfite. Do we need any charges? Or excuse me, any subscripts? Yes, sulfite has a 2 charge. So it becomes sodium's 2 subscript. Number 3. Again, don't worry about balancing the equation. We need to figure out what acid is reacting to give us the following products. So if you notice, acids will always begin with what? Hydrogen. That's going to be one of our good understandings. Then, hydrogen is going to be bonding with the what? Hydrogen is going to be bonding with the anion of the salt. Since hydrogen was right here with the water, to find out our acid, we're going to take the anion from our salt. So what's that first acid? It's going to be acetic acid. C2H3O2 is acetate, right? It's one of our polyatomic ions. Put hydrogen in front of it, it becomes acetic acid. Letter B, hydrogen is now with what? Sulfate. So what acid is that? Sulfuric acid. And then the last one, hydrogen is now bonding with phosphate, so that should be phosphoric acid. By the way, remember how I got each of these subscripts? This was the charge on sulfate, this was the charge on phosphate. You will have your periodic table with polyatomic ions on the test tomorrow. Questions? Good. Identify compounds in the following lists of acids or bases. Identify each either as an acid or a base. Note, hydrochloric acid. Well, I just gave you the answer. Since it starts with the H, it's an acid. Good. 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 And the other ones, if it's a base, it has to have what ion? Hydroxide. Base, 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 and base. Next, acids are proton what, while bases are proton what? Now this is hugely fundamental, and please do not miss this. Acids are proton donors. Proton donors. We mentioned this in our notes. You want to make sure you know those concepts. Acids are proton donors, while bases are proton acceptors. Again, I use the analogy that bases, like a bass voice, like a really deep voice, is like a giant that's coming and taking all of your protons. He's a proton acceptor. Base, proton acceptor. What's the difference between a strong acid and a weak acid? Well, strong acids will completely what? Do you remember that word? Completely, 100%, they will do what in water? Oh, that's not big enough space. What process will they do when they're in water? They will completely dissociate in water, which just means they're going to turn into their respective ions with absolutely no residue. 100% dissociation. That's why they're so strong. Next, the 6 acids and 6 strong bases. For sake of time, you have that list. So just go ahead and go through that list real quickly. Number 9, given the following pHs below, determine if the solution is acidic, basic, or neutral. Now remember, pH scale. 7 is exactly what? Neutral. 14 is the most basic, and 1 is the most acidic. So if it's anything between 1 and 7, it's going to be acidic. Anything between 7 and 14 is going to be basic. So look at 4.4. That's between 1 and 7, so that's acid. 1.6, acid. 7, that's neutral. 12.5, that's basic. How are we done? Good? Okay, next one, number 10. Complete the following neutralization equation. Neutralization, again, is what? An acid reacting with a base. That's an example of a double replacement. So the cations are going to switch places. So now we have lithium bonding with sulfate. Do we need subscripts? Well, what charge does sulfate have? Sulfate has a -2 charge. So it's going to have some crossover. And then what do we know is one of our products as well? Always going to be water. Wait, that is all for the acids and bases component of the test. Now, really quickly for thermochemistry. Number 1, given the balanced chemical equation, sodium plus chlorine yields sodium chloride, which statement describes the process represented by this equation? When we take sodium and we bond it with chlorine, are we creating a bond or breaking a bond? We're creating a bond, right? So we can scratch out B, we can scratch out D, because we're not breaking any bonds, we're forming bonds. We're forming bonds. Every time we form bonds, what happens to energy? Do we absorb it or release it? We release it. Good. So the answer is C. Next, number 2. What type of energy is stored in the chemical bonds of compounds? Well, remember, there's 3 types of energy for this chapter. There's potential, there's kinetic, and there's thermal. So which one is stored in the chemical bonds? Potential. Make sure that you remember those things in terms of the reactants, yielding the products. Remember that the potential energy is found in the bonds of the reactants and found in the bonds of the products, and what's found in the yield sign, what's found in the actual equation, kinetic energy. And then if we lost any energy, what type of energy is that? Thermal energy. Define thermochemistry. Again, that should be found in your notes, so I'm not going to waste time. A piece of hot metal is placed in a beaker of room temperature water, which of the following will occur? So it's hot metal, it's hot, and it's being placed in a colder, it's room temperature, it's going to be lower temperature water. So heat always moves how? From high temperature to low temperature. So it's going to be moving from the metal, which is hot, to the water. It's going to be moving from the metal to the water. So we can scratch out C and we can scratch out D. Heat will move from the metal to the water, and the water temperature will what? If it decreases, that doesn't really make sense. That means it's getting colder, right? The water temperature will increase since it's having energy invested into it. The difference between temperature and heat, again, this has been written on your worksheets and it's on the slides. Temperature is the measurement of kinetic energy. Heat is the movement of energy. Measurement, movement. Name the energy that flows from a warm object to a cool object. Again, that is just thermal energy, also known as heat. When heat is absorbed by a substance, what happens to the kinetic energy of the particles in the substance? Well, as we get a higher temperature, we get a higher kinetic energy. Increase the temperature, we increase the kinetic energy. When heat is absorbed by a substance, what happens to the kinetic energy of the particles in the substance? Increase temperature, increase kinetic energy. The way that we would graph that is that as one increases, the other increases. We call that relationship directly proportional. As one decreases, the other would also decrease. That relationship is known as directly proportional. Increased temperature means increase the energy. Number 9. Well, no, number 31. Let's look at this equation real quick. Nitrogen gas reacts with hydrogen gas to yield ammonia, and look at this, 91.8 kilojoules of energy. We have just produced energy. Energy has quite literally gone from the system into the surroundings. What does that mean? If it's being produced, that means energy is going out of the system, into the what? Into the surroundings. What do we call reactions where energy leaves the system and goes into the surroundings? We call those types of reactions exothermic. Energy is exiting the system. It's exothermic. Now, if we look at number 31, on the labeled axes, down here, draw a potential energy diagram for the forward reaction represented by this equation. This reaction has a large activation energy. So, since we know that this reaction, just by knowing that energy is a product, we know it's exothermic. Since we know it's exothermic, which one is going to have higher potential energy? The reactants or the products? Think about it. If it's exothermic, which one's going to have higher energy? The reactants or the products? It has to be the reactants. Because note, we just lost energy. Since we've lost energy, that means we're going to finish with less. Energy has exited the system, meaning that our products are going to have a lower potential energy. By the way, this says this reaction has a large activation energy. I should have probably made my hill a little steeper to reflect that. Number 32, place the reactants and the products in the proper location on your graph. I'll just label them real quick. That's reactants and products. And label them reactants, products. Number 33, draw and label an arrow to represent the delta H. By the way, what does delta H stand for? You should know this word. Please know this word. If you don't know this word, you need to know this word. It's enthalpy. Again, H. This is the change in heat. how much heat we gain, how much heat we lose. So it is the difference, that means we're going to subtract. It's the difference in heat, of potential energy in the products from the reactants. So remember, to calculate delta H, you can do this equation, the final potential energy minus the initial. Final minus initial. How much did we end with minus how much did we begin with? That will help us indicate if enthalpy is positive or negative, if we have those values, if I have those variables. So enthalpy is that difference. Do the potential energy of the products minus the potential energy of the reactants. How do we know those values, Mr. Allen, you might ask? It will be given to you over here to the side. So it might say 25 kilojoules, or it might say 50 kilojoules. It'll tell you specifically. Number 33, the second part says, and draw and label an arrow to represent the activation energy. Activation energy in the red is just how much energy is needed from the level of reactants to the actual slope itself, to the top of that hill. That's the activation energy, or the energy of activation. Next, on number 13, we have a chemical reaction in which the products have more potential energy than the reactants is, so note, let's think about it real quick. If we have more potential energy than the reactants in the products, the products are up here, reactants are down here. Here is our actual potential energy diagram. We have more potential energy in the products than in the reactants. Let's look at this real quick. To show that diagram, does that look like we've gained energy or lost energy? That represents a gain in energy, and if we have a gain in energy, that means it's what type of reaction? Endothermic. Energy is going into the system. Next, number 14. When two chlorine atoms combine to form a molecule of chlorine, so we have chlorine right here, we have chlorine right here. Well, it says chlorine atoms, so not even molecules. Chlorine plus chlorine yields chlorine gas. Energy is always what? This might look like a weird question, but let's break it down real quick. We have chlorine, and we have chlorine, and what are we doing between them? We're forming a what? We're forming a bond. Let's draw the quick Lewis structure, if you remember this from last November. So we have a chlorine molecule. What did we just do? We formed a bond. Every time we form a bond, what happens? Energy is always released. Always released. When we form a bond, energy is released. Number 15. For the reaction described in question 14 above, do the reactants or the products of the reaction have a higher potential energy content? Explain your choice. You will not have to do anything like that on the test. I'm saying that because my brain is also a little frazzled right now, and we need to go quicker into the video. When a chemical reaction takes place in a container and the temperature of the container decreases, is this reaction endothermic or exothermic? Explain your choice. So, chemical reaction is taking place in a container. The temperature of the container decreases, so it gets colder. If the temperature of the container is getting colder, what does that mean the type of reaction is? Energy is leaving the surroundings and going into the system, going into the bonds of the molecule. So it's going to be absorbing that energy. Therefore, it's going to be endothermic. Some explanations is, you could say, because the surroundings lost energy, or the system absorbed energy. Both those are acceptable. Putting them together is dynamic, so I would recommend doing that. Number 17, heat energy always moves spontaneously. Spontaneously meaning like this is its go-to default setting. Heat energy always moves spontaneously from higher temperature to low temperature. A. From higher temperature to low temperature. If you do remember, and I'll post this on Google Classroom, but you also need to make sure you know the three laws of thermodynamics. If you remember, the first law is that the law of conservation of energy. Energy cannot be created or destroyed, only transformed. The second law is that we will always go from higher temperature to lower temperature, but we can go from lower temperature to higher temperature only if we use work. That's what the second law says. So we could technically say C, but we're not thinking about the second law. We're thinking about what is natural. So, yeah. The third law states that entropy, it would be at its absolute minimum at the temperature absolute zero, but we can't reach absolute zero. So absolute zero is impossible to reach. That's the third law. Those are posted. Number 18. All right, last thing, then we're done. Is the overall reaction, as shown in the diagram on the right, exothermic or endothermic? We start with this much energy, 50 kilojoules. We end with 100. Did we gain or lose energy? We gained, so it's endothermic. We absorbed energy, endothermic. What is the activation energy for the forward reaction? Well, we started with 50, and the activation energy says it's 150. So is our answer 150 kilojoules? No, our answer is not 150 kilojoules. What we have to do instead is we have to say 150 minus 50. 150 minus 50. We already started at 50 kilojoules, right? So we have to see how much energy will we need to gain to actually reach the top, the activation energy. So it's going to be 100. 100 what? Don't forget your units. Kilojoules. If you forget your units, it'll be like minus 1 point, but don't miss points for units. What is the enthalpy change for delta H for that forward reaction? Again, forward reaction just meaning going from left to right. Delta H is the difference between the potential energy of your products minus the potential energy of our reactants. So the potential energy of our products is 100 kilojoules minus 50 kilojoules. That will give us 50 kilojoules. Is that positive or negative? Positive. We know that a few reasons. One, because this is endothermic, so it's a positive delta H. And two, when we do final minus initial, it gives us a positive number. Number 21, what is the delta H for the reverse reaction? So say we went from our products to our reactants. So we went in the backward direction. What's the delta H? Well, basically, we would say 50 minus 100. What is 50 minus 100? Negative 50. So that's negative 50 kilojoules. It would be an exothermic reaction, because we would be starting with more energy than what we finish with. Which has the final, let me erase some things real quick. Which has the highest potential energy, the products or the reactants? Which one has the higher potential energy? The highest, excuse me. Well, hopefully you can visualize that the products have 100 kilojoules, so they're going to have a little bit more than the products. Then what is the activation energy for the reverse reaction? So going backwards, going from our products, going that way, from right to left, what would be the activation energy? Well, let's look. We start at 100, right? We end at 150, so what is that activation energy? 50 kilojoules. We only need 50 kilojoules of energy to actually get the reaction going, because we did 150 minus 100. Last questions. Ready? Then we're done. What is the activation energy for the forward reaction to the left? Okay, we're starting at 60. We're ending at 20. What is the activation energy? So right here, the activation energy is 80 kilojoules. We're starting at 60, so what's 80 minus 60? 20. Hopefully that feels pretty good. You're getting the hang of that. 20 kilojoules. What is the activation energy for the reverse reaction? So say we're going to go from the right to the left. Well, the products have 20 kilojoules, right? And we need to have 80 kilojoules because that's the length of our activation energy in the reverse reaction. So what is 80 minus 20? 60. That's the activation energy for the reverse reaction. What is the delta H for the forward reaction? Remember the delta H, the change in heat, the enthalpy, is the final minus initial. Final minus initial. Our final is 20 kilojoules minus our initial, which is 60 kilojoules. So what would that equal? Negative 40. Whoa, my computer just glitched out. That's okay. We're almost done. Negative 40 kilojoules is our answer. Notice also that forward reaction, let's go ahead and answer number 30. Is the forward reaction exothermic or endothermic? We're starting at 60, ending at 20. So since we're ending with less than we started, we lost some energy. So that's exothermic. Energy left the system. Number 29, what is the delta H for the reverse reaction if we were to go from our products to our reactants? The delta H, again, is going to be the final minus initial. So final, which is 60, minus initial, which was 20, should give us positive 40 kilojoules. Okay, I will post an announcement and send a picture of this answer key. Well, I'll just show you real quick because you can have access to it. If you have any questions about any of these problems specifically, please let me know. Remember to memorize these 6 strong acids and 6 strong bases. Don't forget those. And then email me with any questions you might have. God bless you, and may you have a good rest of